In this lesson, we will define and apply properties of arcs and central angles. So a few terms to know, beginning with the term central angle. A central angle, by definition, is an angle with the vertex at the center. So looking at this picture, one example of a central angle would be angle DOC. So right here, this angle would be a central angle because the vertex is right here at the center. We could also have angle AOC, or we could have AOD, would also be central angles. We also have a term called an arc. An arc is simply a portion of the outside of the circle. So from D to C would be an example of an arc. Or from C to A, on the outside here, would be considered an arc as well. Or from any point on the circle to any other point on the circle, that would be considered an arc. And there is a relationship between the central angle and with the arc measure. So the relationship is that the central angle and the arc measure will be the same. So if measure of angle DOC were, let's say, 40 degrees, then the measure of arc DC would also be 40 degrees. Another term to know is what we call a minor arc. A minor arc, by definition, is an arc that is less than 180 degrees. And when we say 180 degrees, keep in mind that a circle has 360 degrees. So we are saying that a minor arc would be less than 180, which is less than half of the circle. So for example, the arc from D to C, the one we mentioned just a moment ago, would be considered a minor arc because it is less than half the circle. CA would also be a minor arc, so from C to A, because it is less than half the circle. And then we have what we call major arcs. Major arcs are more than 180 degrees, meaning more than half the circle. So for example, if I were to go from C, starting here, to D, and then going all the way around to A, that would be considered a major arc because it is more than half the circle. Or we could go the other way, from C to A to D. That would also be a major arc. Now notice how I am writing the minor and major arcs. The minor arc, I'm using 2 letters. Major arc, I'm using 3 letters. The reason is, with arcs, we are writing the letters of where it starts and where it stops. So the arc DC would start at D and end at C. Arc CA would start at point C and go all the way to point A. Actually going this way. But the question is, if you did not specify, how do we know which direction the arc is going? Are we going the shortest route, or are we going around the long way? So to signify which direction we're going, we use 2 letters for a minor arc, but a major arc uses 3 letters, meaning that we are going the long way. So we have CDA, meaning we start at C, we go around through point D until we reach point A. So we're going the long way around. Same thing with CAD, means we're starting at C, going through A, then going around to point D. Another term we have is what we call a semicircle. A semicircle is exactly 180 degrees. So for example, we have ACD, so starting at A, going through C, and then all the way to point D. And we also have ABD, which means we're starting at point A and going through point B, then going all the way to point D. And notice once again with the naming of semicircles that we're using 3 letters to represent semicircles as well. And the reason is, once again, if I just said semicircle AD, we don't know which direction we're going. Are we going around to the top or around the bottom? So to signify which direction, we need a 3rd letter of a point that the semicircle is going through. So that is why we have ABD versus ACD. The next term we have is the term adjacent arcs. The word adjacent means next to, and so adjacent arcs are next to each other. And not just close in proximity, but they need to be sharing a point. So that is our definition of adjacent arcs. They're arcs that have one point in common. So there are multiple examples in this picture. One example would be CD and AC. So CD would be from C to D, so this arc right here. And then AC would be going from A to C, so this arc right here. So notice they have a common point, point C. So therefore, they would be adjacent arcs. The next term we have is the term congruent arcs. And now we've seen the word congruent in multiple different contexts. But once again, the word congruent means shapes that have the same shape and the same size. So congruent arcs, by definition, are arcs in the same circle or in congruent circles that have equal measures. So here, if BD, let's say, had a measure of 40 degrees, and DC also had a measure of 40 degrees, then we can conclude that BD and DC would be congruent. And by the way, it is important to realize that it needs to be in the same circle or congruent circles. Because if I had a small circle like this, and I had an arc, so right here, maybe an arc, and this arc was also 40 degrees, notice how much smaller this arc is. Even though, yes, they have the same measure, they're not the same size. Because if I were to actually get a tape measure and measure from this point to this point on the outside of the circle, that would be much smaller distance than from point B to point D on this circle. So it is important to make sure that we are in the same circle or in congruent circles. Now we're going to use information that we've been talking about to find the measure of arc AB. So arc AB would be from A to B. So what is the measure of this arc? Well, the measure of the arc would be the same as the central angle measure. So looking at the angle that creates that arc, so the angle that creates that would be right here. So take these two endpoints and draw it back to the center. And this angle, the 60-degree angle, creates that arc. So therefore, AB would be the same measure as the central angle. Next, we're told to find the measure of arc AC. So if we know AB is 60, angle AOB is 60, then we know BOC is 80, and then DOC is 40. Using that information, we're trying to find the arc from A all the way to C. So notice the angle that creates that arc. The angle that creates that would go from A to O, and then from C to O. So this angle right here, angle AOC, creates that arc AC. Well, if we were to add 60 plus 80 together, we get a measure of 140 for this angle AOC, which would mean that because the central angle and the arc that it creates are congruent, then arc AC would also be 140 degrees. So that is what we call the arc addition postulate, which says that the measure of the arc formed by two adjacent arcs is the sum of the measures of these two arcs. So we know AB would be 60 degrees, and then arc BC would be 80 degrees, the same as those central angles. And so if we just add 60 plus 80 together, we get the measure of the bigger arc, arc AC. So that is what we call the arc addition postulate. And that concludes our lesson for today. We will see you next time.